My name is Isabela, and I'm going to present my dissertation that is automation of sub-process in the design stage. So as we all know, BIM have brought a lot of improvements to the AC industry. Many countries have brought several legislations that demand the use of BIM models for public project approvals. However, in a lot of countries, the use of 2D drawings is still mandatory, as we can see in the map. That in red is mandatory, yellow and orange, they are creating the rules about it. And the creation of the deliverables takes up 41% of the time needed in the development of the project. So the objective of this dissertation is to address the process of creating deliverables, making it more efficient with the use of automation. Automation is the process of using machines to test once performed by humans or to tasks that would otherwise be impossible to do.
Sorry, Marin, would you please mute? Thank you.
The use of automation in BIM is already applied in several areas, such as scan-to-BIM, crash detection, and automation of quantity takeoff. When it comes to automation in the design stage, there's 3 phases according to RIBA. As we can see, each of them has certain areas where automation can be applied. In the concept design, automation can be applied in the generation of design propositions and feasibility studies, aligned with the site information and initial solar analysis. In the spatial coordination, it can be applied in testing and validating the concept design, like tools to automate model checking for building permits. And in the technical design is related to the preparation of information necessary for the construction of the project, like automated extraction of quantity takeoff and automated views generation and automated placement of them into sheets. And how these automations can be developed? Well, there are several areas, and the most used one is with VPL, Visual Programming Language, text or programming language, add-ons, plugins, and softwares. To address the issue related to the creation of deliverables explained before, a methodology was proposed. In collaboration with the company, a list of the most time-consuming sub-process was created, which is presented in the slide. The approach of solving the listed sub-process was following the logic displayed in the process map. First was investigate if there is an available solution on the market such as add-ons, plugins, and if not, a solution using VPL within Dynamo was created. After, a study was conducted to assess what is the time saved using automation compared to the conventional methods. Now we go through each one of the 15 sub-processes and the way that they are solved. One of the main issues in the exportation of drawings is the misalignment of the floor plans on different sheets. To address this issue, a variety of available tools were tested and evaluated, and the Tiny 2 add-ons turned out to be the most effective one since it aligns the floor plane based on a project point of reference and not with the view crop or the viewport. In the figure shown on the slide, we can see the result obtained by the use of the add-on. That even with different viewport size, it aligns the views with the same alignment of the project. In the project handover phase, the data regarding the revisions must be placed on each sheet. Until Revit 22, this had to be done manually for each sheet. And since the company uses previous version of the software, for them it was important to automate this sub-process. And it was done using D-Roots 1 sheet chain add-on, which allows placing multiple revisions in multiple sheets at once. One of the most time-consuming sub-processes is the creation of dimension annotations. That was solved using Glyph plugin, and it has two possible approaches to do it, by view or by line. The creation by view is done automatically, whereas the creation by line follows a path defined by the user, dimensioning the selected elements. As we can see in the figures, the method by line is more precise since the selection of the elements is more detailed compared to the method by view, where a lot of overlapping happens to occur, even using an option that is that the plugin has to avoid the collisions. And also because when you do by line, you can choose where the annotation dimensions will stay. When it comes to elevation and sections, both methods have limitations. By line is not working at all, and by view only allows dimension using levels at references. One of the frequent issues occurring during the creation of the project is renumbering elements, and it can be very consuming when, for example, we move or delete one of 100 parking lots. It requires renumbering one by one of them. The routes one ordering is the add-on that allows automatically renumbering elements through several ways, manually, crossing, vertex, and auto. The most effective one is crossing that allows users to define the path as the order in which the element should be renumbered, because using the auto method does not follow the conventional way of reading. The following slides will address the subprocess solving using Dynamo scripts. When placing the views on sheets, the view title aligns with the size of the viewport. However, often changes in the view crop and alterations in the product leads to the misalignment of the view title. To address this issue, the company asked for the creation of two scripts, one choosing the position to place the view title, and the other to align the view title with the viewport size. For the alignment of the viewport, an existing node was used, and for choosing the position, a Python node script was written. Clash detection softwares detects intersections between 3D elements. However, intersection of two elements is neglected, leading to the levels of bad quality and accuracy. To solve this, a script was created. It consists of getting all the elements in the current view, then the user selecting two elements for overlapping checking, and graphically display with color overrating the ones that are overlapping. This script can be used in any type of view, floor plan sections, elevations, and 3D views, and also work with 3D elements. When placing rooms, areas, and Revit space, the software does not use any reference points to place them. To address the visual aspect of the creation of the deliverables, a script for the centralization of this space was developed. For rooms and Revit space, an existing node was used. However, for areas, there was an existing one. For that, was necessary to modify the existing node used for rooms, changing the bytecode embedded in with information obtained from Revit API. This script can also be used as a starting point for other centralization scripts. For example, placing light fixtures in the center of a room space. Deleting rooms, areas, and Revit space in views does not actually remove the element for the project. Getting the not placed to get the not placed elements is necessary to create a schedule, and this can be very time consuming when working with a large project because there's a lot of elements. For this, a script was created to automatically detect and remove all spaces not placed simultaneously. So it's not necessary even to create the schedule. The script deletes all the not placed ones. Often dimensions annotation have to have the zero value of dimension. Usually it happens when we copy a dimension annotation from one level to another and the reference gets lost. This script solves the issues and could be used in combination with the previous mentioned plugin for the automatic creation of dimensions, because it happens a lot of zero dimensions using that plugin, and it can facilitate a seamless workflow. The second script display on the slide addresses the placement of the spot elevation aligned with an offset from the center of the room. And the descriptor of centralization of the room was used as start point for this one. Placing them with a reference point leads to a better quality of drawings. Since the company has an established standard regarding the placement of light switches, a script was created to ensure that the standard is being followed. Running the script, it places light switching, referencing all chosen type of doors and respecting the predefined dimensions. For placing the stair pad in every stair of the project, it's necessary to click in each one of them one by one in every view. This script solves these issues, automatically placing the stair pad on all the stairs of the project once. And for placing the north symbol in all floor plans in the same place, it's necessary to place it in one view, adjust the angle, and then copy-paste a line in all selected views. Essentially, the use standard is to use as reference point the upper right corner of the sightline to place the north symbol. The script was developed to ensure that the distance from the point is fixed and the only input is the north angle. Although using DynamoScript saves a lot of time during the project development, running the script with DynamoPlay shows loading and execution time duration issues. For the company to use the script, the main request was for them to be accessible and easy to run. A solution was found using the Nika plugin, which allows the integration of the script in the toolbar, creating a button from each script. This allowing running the script faster and, unlike DynamoPlay, loading performed only in the first execution of the script. To evaluate the efficiency that can be achieved using automation, a case study was performed, comparing the time needed for manual execution tasks versus automated execution. Although the majority of the tasks does not show a significant in saving time, the overall result shows a major difference in duration, with automation execution being roughly 2 times shorter. The highlight tasks are the ones that show us as the most time-saving ones. The results of the performance study show a 57% reduction of time spending when using automation. This percentage confirms the need for automated process within the context of BIM and achieved its objective of proving that automation can help the process of creating deliverables, make them more accurate, and with a reduction of time needed to be produced. It's important to note that this work can be developed further in several ways. The add-on plugins and scripts could be tested in different scales of types of projects. They can also be optimized and enhanced. In conclusion, as the AC industry continues to evolve, embracing automation as an integral part of the design process helps the process to be streamlined. Thank you all.